You already stacked your pictures in WBPP in part 1. You already did the basic processing steps in part 2. And now we're doing everything that is needed to bring your pictures to full glory. And that right after the trailer. Hey, this is View into Space. I'm Sascha from Switzerland, so grüezi miteinander, and thanks for watching my channel. Now, what does actually change in this third part? First of all, we change a few processes from the easier version, like the automatic background extractor, to the better version, the dynamic background extraction. But then we also add a lot of new processes and scripts that are coming from external. And I will show you how to do that. Now there's some which are free, like the generalized hyperbolic stretch, but then some other processes which I will propose you to use in this process, they're not for free. And that's the Astro tools, the blur exterminator, the noise exterminator. And while this is not covered in this tutorial, I also would recommend you to acquire the star exterminator. Now, I think it is crucial to address that. What it will cost you if you buy all three of these processes is around $200. There are some discounts if you buy more than one process from Astro. So overall, all three processes together, $200. Now I understand that given you just started with PixInsight and PixInsight is not cheap, you might believe I'm crazy. So you have to pay a lot for PixInsight, and now I tell you to double down and pay another $200 for additional processes. The point from my perspective is this. PixInsight as itself is a great tool, but beside SPCC, there are tools like Serial who can almost bring you to the same level and which are free. What makes PixInsight really a killer app are the Astros extension. If you want to use Blur Exterminator, you need PixInsight. If you want to use Noise Exterminator, you need PixInsight. So for me, this is like a symbiosis. It's just belonging together. It's from two different providers, but at the end it's one. And there's two arguments I can give you. First of all, if you do not buy these processes right now, I guarantee you, you will do it later on. But then you will actually have to reprocess all the pictures that you now processed without them. And the second thing is, $200 is a lot of money. I understand this. But how much money do you spend on equipment? And I know it's so much cooler to buy a new filter or another camera because you have something in your hands. But actually the truth is that these processes improve your pictures much more than any hardware could do for this or even double this price. And by the way, also for the Astro tools, there is a trial period. So because seeing is believing, please download the test versions, try it out and see the difference for your own eyes. Because I could say everything, but when you try it out and when you really see the improvements your picture make with these processes, then you will understand. And to download the trial versions or the paid versions, please have a look in the description below. You find all the necessary links down there. And with that, I would say let's go to the computer and let's get started. Okay, and here we are again on my computer. And we start exactly at the same point as we started in part 2. But this time we have the better tools and we can do it right. Now when we talk about the better tools, we know now what they are and we will use it, but before we can use it, we have to install them because a lot of the tools that we will use are not default in PixInsight. And the good news is that this is really easy. So what you're doing is you go to Resources and then to Updates and then to Manage Repositories. So these are all the script repositories that I have. And the ones that you need are the sky pixels, all the ones from RC Astro. As mentioned, we will not use Star Exterminator in this tutorial, but also as mentioned, I recommend that you also already install it. You will 100% for sure use it later on. And the last one we also need is the GHS Astro. So I will put these links in the description below. Now there's one crucial thing. Do not click on these links and then write in the comments that they do not work. This is not how these links work. But what you do with them, you click here on add, you copy paste now one of these 5 links in here, and then you say okay. And you do that with all 5. And then they're listed here. And when they're all listed, you click here, okay. Now you might assume they're already installed, but they're not. So what you have to do, you go again to resources, updates, check for updates. Then it checks for updates and it obviously finds them because you do not yet have these 5 scripts. I at the moment have no updates, but it will find them. And then you just say install them. And you will then have to actually close PixInsight. It will then install the scripts and restart it. And then everything's fine. And then you can just go for checking in process, all processes. And then you actually should find here the generalized hyperbolic stretch. You should find in here the blur exterminator, the noise exterminator, the star exterminator, and in script under render, you should find PSF image. And that's all the new things that we installed. And now that we have done that, we can actually start having fun and beautify this picture. So remember, the first thing we did last time was that we used the automatic background extractor to get rid of this hideous gradient. And as we also remember, this didn't work well. So we definitely need here a better tool, and that's available in PixInsight. And for that, we go to Process, All Processes, Dynamic Background Extraction. Now for a lot of these tools, which are a little bit more complex, I actually created, at one or the other time, separate process tutorials. Now I will explain you in this rather long tutorial here a lot what is needed to actually do it on this specific picture, but I cannot do everything. So if for one or the other process you feel you want to know even more information, I will leave links in the description below to all these separate process tutorials, and you can get there even more information if needed. So the dynamic background extraction has the name dynamic in the name. And whenever that is the case in PixInsight, it means that the process interacts with the picture. So here we do not have a real-time preview because we don't need it. So how we do that is simply we click into the picture and you immediately see here these crosshairs. And that means now the picture is connected to the process. Now what we have to do is we have to set samples. So we actually guide the process what the gradient is, what the background is, what the gradient is, but not what the signal is. And there are different ways how this can be done. One is we start here just by ourselves to set samples. When we set a sample, you see there's this green little checkbox now here. And the good part that PixInsight does, it actually shows you the content of this sample here. Now it's really colorful. And what this really colorful means is this is actually not really taken into account. This is too strong. But we want to have this taken into account because this is our gradient. So you go here to tolerance and you increase this from 0.5. Let's take 2. Now you see you have already less of these colorful pixels, but you still have them. So we go up to 3. There's a few little left. So I think with around 3.5, we should be fine. 1 or 2, it's okay. The next thing we can do, this is now a sample radius of 18. This is rather small. Now we can say we go up with that to about 40, for example. And we say resize all. Okay, much bigger. Now you see this here, this is a star. Now in a lot of tutorial you hear This is a problem. Move it somewhere where there's definitely no star, like here. Now, is this really needed? And the answer is no. Because, as you can see, these stars, they're actually almost black. And what this means that the process disregards them. It ignores them. It doesn't matter. So I can even put something here. It doesn't matter. The only thing that we do not want is, for example, to put a sample here. Because this is not a gradient, this is the nebula. And this is something we want. Now, as stated, there are two ways how you can do that now. Either we start now and set samples wherever we feel is a good spot. And we will go on and make about 40 samples all over. When should we do that? We should do that when we have a lot of complex nebula in the picture. Because then we really have to very consciously search for places where there's just background or gradient, but no nebula. Otherwise, we start to erase the nebula. And that's definitely something we do not want. But in this case, we just have these few stars and this little tiny little bit of nebula. In such a situation, we can take a much easier approach. You see here samples per row. 10 is a little bit less from my perspective. We go to 15 and we say generate. Whomp. And now we have samples already set evenly all over the picture. Are we finished yet? No. Because you see what happened. Here it actually set samples at the nebula. What we do, we take this, that we have here this little arrow, and we drag and drop them somewhere else. Doesn't really matter that much. Here we can make sure they're not really on stars. And personally, I would just take them out of this area of the Pleiades. Because we don't really know where there's a little bit of nebula. We definitely don't want to be too close to that. We could also, by the way, delete them. Just here the little X, and it's gone. That's the other way. I would definitely put a sample here on this odd little thing. We already know we have here kind of a spot. We want to have this gone, so it's good that this is sampled. I sometimes don't delete them because I feel it's actually good having even a little bit more samples, at other places. So why delete them? We can just move them a little bit around. This is the only thing you really have to be careful that you do not mess with the nebula. Because if we do not want to do one thing, then it's actually remove the nebula. But otherwise, all these stars don't matter. Except you would go here in a tolerance limit that is so high that the stars would start to fade. Because then they would be in scope, and that's definitely something we do not want. Once we have done that, we go here to correction, we take subtraction, and we let it run. Now let's first of all look at our map, and you see we have a very nice gradient, which also shows that actually here's the dark spot and it's all around here. So it looks much better than we had in the automatic background extraction. So let's look at our picture now. And isn't that nice? I wouldn't say all is gone, but it definitely looks much nicer than what we had before. So now again, we can actually try to redo it and to see if we can get even the rest out. How would you do that? Because we want to recycle here the sampling. We do not want to start again and do the sampling again. Take the little triangle here and drag and drop it on the background. You get this process one. Now you close down the process. Yes. We close down our old picture. We do not need that anymore. This is definitely better. And now double click process one. And you see what happens. Now we have the samples on our new picture. And we do not have to redo them. And all we do now is we start the whole thing again, and let's see what happens. Let's look at the map. We see there's still some stuff here removed. Let's look at our target picture, and it's very nicely visible that we have actually here much less than here. So I think that's okay now. So we close everything down. We close the process down. Yes, we do not need the old one again. We will continue with that. and we close the process here. You just right click here this process and you say delete dynamic background extraction. Okay, what comes next? As in the last time, SPCC. But there's a twist this time. We assume you do not have it plate solved because you stack this picture in another software, for example Deep Space Stacker or Astro Pixel Processor, or you cropped it after stacking, or it simply failed. All of that is possible. In all of these situations, what we do, we go to Script, Image Analysis, and Image Solver. So how do we do this plate solving? What you do is you go here on Search, and you look for Pleiades. You find them, and you say, okay, now this is in here. Next thing is you choose the year, month, day, and time when you shot this. Next thing, you choose the focal distance of your telescope. Also remember here to take into account reducer if you used one, then you actually have to reduce it. So effective focal length that you shot it with, and the pixel size of your camera. And once you have done that, you press here OK. Now, if it actually failed during the stacking, there is a very big likelihood that it will fail here again. And what you do then, you go to Advanced Properties. And now there's a lot of things you can play with. From a minimal structure size, to hot pixel removal, to noise reduction, to the sensitivity, to the maximum distortion. You have so many possibilities where you can alter, and I cannot really give you any guidance here. It's just trial and error, trying to convince this tool that your data is now good enough to accept it. But also, if it should fail, just check again here that you really entered everything. Anyway, once everything is fine, say OK, then it runs. And this is done, and we have the picture plate solved. Good. Again, that is only relevant if it was not successfully plate solved by WBPP. If you stack with WBPP in most cases, you will not have to do this step, but I just wanted to show it to you. Now I will fast forward through SPCC, as we actually have already covered that in our last tutorial. Okay, it looks really nice here, and this is done, and we close this down. Also here, by the way, I have for SPCC and for Image Solver separate process tutorials if you're interested. Now with that, we come now to the two processes of RC Astro that we will utilize in this tutorial. This is obviously optional, as everything is optional, but it will make a huge difference in your processing results. The first thing that we need is the Blur Exterminator. And here is it, Blur Exterminator. Now, no matter if you already bought it or if you have a test version, the first time you actually have to go here to the wrench and enter here the license data that you received by email. Otherwise, it doesn't work. You might also have to select here the AI. And you see here there's AI2 and an AI1. So just take the AI2 and open it. And once you chose the version 2, it will always stay like that. Now, Blur Exterminator, if you haven't heard of it, it's a deconvolution tool. So it kind of sharpens the image. It kind of brings out the contrast, the detail. But there's a few things that you need to know. For example, with this image, I want to remind everybody again, this is only 20 minutes integration time. And I also want to remind everybody that we have, because of that, a lot of noise. Now, probably the good thing is that Blur Exterminator is no magic tool, which means it cannot recover data that is not available. So if you have only a short integration time, if you have a lot of noise, a lot of the detail is actually drowned in the noise. And whatever is drowned in the noise cannot be recovered by Blur Exterminator. So the effect that we might see here is not as big or as wow as you might think. On the other side, if you would have here a picture with 10 hours or 20 hours, integration time, it is substantial what Blur Exterminator can recover. Just what had a very low contrast, but was there all the way along as data, just too faint to really be seen. Now there is one thing in addition that we will do before we use Blur Exterminator, because by default you have here automatic PSF. So the PSF is the point spread function. So how much the light is actually distributed, you could say blurred per object. The lower the PSF, the better, the higher up, the worse. So Blur Exterminator can actually estimate that automatically, but not that optimally. And that's something that Russ Croman actually admitted, and perhaps in one of the next versions we will get here something better. But it is worth, and that was demonstrated over and over again, to actually really measure that ourselves and then enter it here to get the best results. So how do we do that? As mentioned in the beginning, we added another script, which you find in script render PSF image. You just open that up and you say evaluate. Now, depending on the stars that you have on your picture, this might take from a few seconds to the length of a coffee or 2 coffees, something like that. You see, I already talked a while and we're already only at 6% because it found 3,519 stars, and it has actually now to measure all of them, and that just takes some time. So I will speed this up now. So this is finished now. As you can see, we have a lot of data, but we just need 2 numbers. Here, the full width half max on the x-axis and the full width half max on the y-axis. Here we have 2.72, here we have 2.31, gives an average of 2.51. So we remember that, we close it down, we go here in Blur Exterminator, we remove here the automatic PSF, and we put here this lever on 2.51. Okay. Furthermore, here in options, we select correct first this here. Now the next question is stellar adjustments. How much do we want to sharpen the stars? So the more we sharpen the stars, the smaller they get. And that's a little bit something of trial and error. There is actually a real-time preview, and I do not like it. It's just, anyway, it takes long until it's always calculated, and it still doesn't really show, from my point of view, the real outcome. So I rather let it run through, and then when I feel the stars are too small or whatever, I just do an undo and I do it again. Because you do not need 10 iterations. It's usually 1, and then you feel, okay, it's a little bit too much, a little bit not enough, and then it's good. The other thing here, adjust star halos. You see, we have here obviously some halos, and we can say we want to remove them. So here, to actually sharpen the stars, we go in the plus range. To adjust the halos, if you want to reduce the halos, we go in a minus range. But you could also say you want to actually make the stars smaller, but you want to leave the halos or even increase the halos to preserve color. So you really have to play a little bit around with that. With the non-stellar adjustments, I usually leave it at the 0.9, so I really want to have it full of Blur Exterminator. But if you would see that it does something strange, which usually happens more in the areas of galaxies or clusters, you might actually have to reduce it here. Once this is all done, we just take the triangle, throw it on here, and let the Blur Exterminator do its magic. And here it's done. So you might have seen that it changed massively, but let's just look at that a little bit more in detail. So let's press the undo button, and now let's redo it. Now what you definitely see is the effect on the stars. That's quite massive. But what you also might realize that when we look at the nebula, the effects are minor, and that's exactly what I told you. This is not enough integration time to give you a wow effect, because most of the things that Blur Exterminator could actually recover are drowned in the noise. And that's just something very, very important to remember. And that's also a motivation to really strive for a lot of integration time, because then you get really rewarded by the power of the Blur Exterminator. With that, we can close this process and we go to the next process of RC Astro, and that's Noise Exterminator. So process, all processes, and here Noise Exterminator. Same game here. If you have for the first time opened it, go here to the preferences and enter your license information. Also select the AI. It's also here AI2, which is at the moment the most up-to-date one. Also here the default is 0.9, only denoise as much as you need, but also to the extent that is needed to really get rid of the noise. And personally, I will leave it now here to the 0.9, which is the default, because the noise is quite hideous here and I want to have it gone. So I take the triangle now, throw it on here. It takes less time, much less time than the Blur Exterminator. It's already done. So let's see what it has done more in detail. So we're zoomed in. So let's do undo. I hope even in YouTube this is visible, how stunning this is. This is really like day and night. And as I stated in the last part, there is just no other noise extermination tool which can do that. None that PixInsight has by default, and none that is available for free. Also not easy denoise, not even close. This is just pure magic. So this is really an amazing tool, the Noise Exterminator, and you have seen how fast it has done it. And at this point, I want also to tell you that it is absolutely crucial here to keep exactly this sequence as I've shown it to you. First gradient removal, then SPCC, then Blur Exterminator, then Noise Exterminator, only then and now we stretch. And never ever let yourself convince that there's another more ingenious sequence. And don't take that from me, take that from Ross Croman, who created these tools. And he states that in the manuals. By the way, it's absolutely great if you read the manuals of his tools with all the instructions. But he also explains it, and also in tests, it has shown over and over again that this sequence makes the most sense. Now we are already, and I hope you agree with that, we are already on a much better level than we were in part 2 with adding these few tools. And now we come to the stretching. The stretching which was in part 2 something very easy. And the stretching that we will do now in this tutorial is, and here a pre-warning again, the most complex part of this tutorial. But also, it's the part which will make the biggest difference to our end picture, probably in this situation, even the bigger change than the Blur Exterminator. Because what you're seeing here, and what is really kind of annoying, are all these structures, and I don't even know from where they come. If this is the flat, which was not 100%, but there's some stuff going on that looks just hideous. And you have seen that this was transported to the end of the picture in part 2. And we can get rid of this stuff, which will make it look so much better than what we had in part 2. So we will actually use to stretch this picture 2 stretching methods, not only one. We will first do the ArcSinhStretch, and after that we will do the generalized hyperbolic stretch. And the reasoning is the following. The ArcSinhStretch has the ability to boost colors of stars. So I usually use it if I have extracted the stars and then only stretch the stars, or in a situation like this where there's just this little itty bit of other stuff, like here this faint nebula, which is also okay if it gets a little bit more colorful. In case of large nebulas, I do not use the ArcSinhStretch because there is usually anyway already enough color. So we would deal with that in another way. And why I not only use the ArcSinhStretch is the ArcSinhStretch, if you would use it for the full stretch, you would have a carnival here with red and blue stars that would look hideous. So we have to use it just this tiny little bit that is needed. So for that, we go now to Process, All Processes, ArcSinhStretch. When we have actually activated the ArcSinhStretch, now the next thing we have to do is we have to activate the real-time preview. Now we state here estimate black point. Then we state protect highlights to ensure that we do not blow out stars. And then we just click up here on this red cross to get actually the auto stretch removed. And now we see what we're dealing with. Now with the stretch factor, we start moving it up until we see that the stars start reacting. And with that, we say actually execute. Takes a moment. Okay. We close the preview down. We close the ArcSinhStretch down. And we have it done. And you already see if we zoom now in that these stars are already very bluish, greenish, whatever. And that's okay. We're now going, again, process, all processes, to the generalized hyperbolic stretch. And here it is. Again, we're opening a preview. And now I know this is complicated, but stick with me. But here I definitely recommend that after this tutorial, you look at my separate process tutorial for the generalized hyperbolic stretch. Because this is one of the most complex processes in PixInsight, and it would just take this whole tutorial actually to show you each and every detail here. This is the stretching method that is mostly used today in PixInsight because it is by far the best. So stick with me now. Please press here on the graph on the magnifying glass, the plus. And what you will see now is a curve. Now in the middle of the curve, click. And you will see this orange-yellow line. Once you have done that, you go down here to the readout data and you see a button send to SP. Press this one. And you will see it has taken the data here, this value, and put it down here in the SP field. With that, go back up here to the most right button and say reset zoom. Now you go here down to local intensity and you put this on about an 8. Then you go protect highlights here and you move this back. Again, this is to protect because we have a lot of stars in here, so we don't want to have them blown out. And with all these adjustments made, we can start stretching with the stretch factor and start carefully to move it in this direction. And you see the stars appearing now. We're not going too far, just a little tiny bit. We want to have that already here. And then we say apply. That's okay. Don't be shocked if you see anything like that. Just reset. Looks already nice. And you see now that now the curve is actually appearing here. Now, if it would be a nebula, this would already be here in this area. But as we have here mostly stars and just these few faint nebulas, the curve is still very much in this corner, and that's okay. Now go again here in the graph, stay a little bit on the right of the graph and click OK. Say again, send to SP. So we have it again down here, and you see it's now further in. Now with the local intensity, I would go only up to about 3 now. What this actually means is local intensity, it's the area in the curve that we're stretching. The higher up we are, the more of the curve is affected by our stretching, and the more we move that to 0, the less we actually affect. And given we only really want to work here with the stars, with this faint nebula, we keep it rather on the low side. And now we're again protecting the highlights, and we start again to stretch. And I think that's about okay here. And we click again. Now, once we are in these areas, we might not even have to reset anymore. We can just continue where we are, because you see that actually that next iteration looks actually pretty nice. And we can even say we practically can accept it like that. We can obviously experiment here a little bit further. You can even increase that here a little bit. Nice. Look how beautiful it comes. Good. I'm actually really happy with that. Okay, now there's something else we're going to do before we exit here. We reset everything. We go here to linear. And now in the low clip, we just change the last number here from a 0 to a 1. Press enter. Doesn't work, so we go up to until it reacts. It changes the number here. And that really depends on the picture. And here actually I have to go to 0.99. And you see it got a little bit darker. It declipped now 0.1% of the picture. That I can work with. But that's just in principle the tipping point where I start clipping. I don't really want to clip, but I want to get it as dark as possible from a background point of view. I say apply, and that's done. And I execute the generalized hyperbolic stretch. And here we are. And I know this was now much more work than just doing the screen transfer function as we did last time, but look at the difference. So when I showed you last time these differences between what we got at the end of part 2 and what I got out of what I just showed you now, the majority of it is thanks to this of the stretching. So if there's one thing I want you to learn from all 3 tutorials, it is this here. Investing in the right stretching method really pays off. And actually, compared to the noise exterminator, the blur exterminator, which is also great, but this here is for free. It only costs your time and your dedication to learn this process correctly. And for that, I just want to repeat that. Please also look at my dedicated GHS tutorial. I will put the link in the description below. And now we are in the nonlinear stage and we continue here. So now what comes next? One option would be we could now go into the curve transformation tool and play around there. We could change hues, we could actually do the S-curve. Now this again is a decision picture by picture. Here, this is not something I want to do right now because this looks cool. So I might at the very end play around a little bit with it, but at the moment, no thank you. The same goes with saturation. We could boost the saturation if needed again. And you see also, we had to do that last time. We had to do the curves transformation, which took some time. We had to do the saturation, which took some time. We do not have to do them now because it's nicely saturated. The colors look accurate. It actually looks good. And that's also thanks to the right stretching. So the next thing I want to show you is called exponential transformation. And what it does, you will probably immediately see when I push the real-time preview. It actually increases the brightness of the objects while it keeps the background rather dark. And you see that now very nicely. Now this is an absolutely great process, mostly for Nebula. Now, do I want to use it here? Definitely not like that. It looks like it blows everything out here. So we have to be careful. But if I go now to 0.3, a little bit more brightness, a little bit more sure, looks nice. I'm going to do that. And a great process I want to show you, which also very complex name, local histogram equalization. What is that? Nuclear physics? Rocket science? No. All it is how PixInsight calls contrast. This is all, contrast. So we click again, real-time preview, and that's something I have to get used to. If you click real-time preview by this process, the preview will always look hideous because the numbers here are completely pointless. Now, I know if you would go into Photoshop or whatever, you would have this one lever here. You could go from no contrast to a lot, and that's all. This is not like it works in PixInsight. It has to be complex. So, first of all, we have here the kernel radius. What it actually is how big are the objects that we want to increase the contrast from? Are these large objects like full nebulas, or all this, just this little tiny structure within a nebula. So we usually start from big and go to small. So large is usually around 150. That's just numbers you have to write down somewhere, but again, they're not etched in stone, so you can also play around and see the effect. So you see if I would go higher up, it would change it also. But usually 150 is a good starting point. Contrast limit. The reason why it looks so hideous is because 2.0 is way too high. So it just completely destroys the picture. So my magic number, which I use, again, this is my magic number, not yours. So try it out. Perhaps it works for you because you have a different taste. I use 1.3 and you will see immediately it looks better. We can actually switch here. There's definitely something happening. And here the amount 1.0 is still too much. So usually you would go between 0.4 to 0.6. That would be about what you would be doing. So let's see now. And that looks actually nice now. It's even still, from my taste, a little bit too much. 0.4. Yeah, I would say that definitely helps the picture. So execute it. And this is done. Now we go down here to about 60. And 60 are now the small structures. We leave the contrast limit at 1.3. We also can leave the amount here already at 0.4, and we just again toggle. Does something happen? Do we like what's happening? If not, or if it's not enough, we can actually move this up a little bit. Let's see. I'm okay with it. I execute it and done. I close this down. And now practically as the last thing, we go to the curve transformation again to just clean the whole thing up. So you see that we do not use the unsharp mask here because Blur Exterminator did that for us. So curve transformation, we need a preview. Now what do I want to do actually? And that's always, it's good with all these processes in principle, if you have a strategy. And especially in a process like the curve transformation where you could do everything. Hue, saturation, brightness. So if I look at the picture, I like the saturation. I don't want to have more colorful. I like the hue. It is nice and bluish. The only thing that I don't like is still these kind of hellish spots here, which they're just a little bit too bright, and I want to see if I can make them disappear without making the nebula disappear. Now when we look here, we see this is actually rather low, which gives me hope. So let's look at the nebula, and you see the nebula is way, 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 way higher. So that's good. So if we say we put around here the S-curve, and we draw this line down now, yes, these spots disappear and the nebulas get brighter. So while I like here that it gets darker, I do not like here that the nebula got so bright. This looks like over-processed, blown out, but we do not have actually to leave it like that. We can simply take here the curve and flatten it out again. You see, now it's completely flat again like it was before. Let's look at it, yes, but we got rid of all this awful stuff. Great. Now the last thing we obviously can do, and given I haven't shown that in this tutorial, I will do it now, we can crop this thing. Because at the end, it's not a star field with a little bit of Pleiades, but it's the Pleiades. So let's go to Process, Dynamic Crop. So it's again a process with the dynamic in the name, but this time we do not click in it, but what we do is we click Reset. And when we click Reset, you see it gets a frame, it gets a little bit pale. And now we're actually going here to the border, and you see how the icon change. It gets this little fat thing on the bottom, and now I can click it, hold it, and move these walls in. And once you're okay, just click the green hook. And it just tells me that when I now crop, the astrometric solution will disappear. That's what I told you at the beginning, but that's okay now because we don't need that anymore. So yes, and here we have it cropped. And here we go, the Pleiades. So looking at it now, we could ask ourselves again, like in part 2, is this a good picture? And I will put it in a context. For 20 minutes integration time, this is a really, really good picture. If a picture with 20-minute integration time can be good, and that's another discussion. But we got rid of all the noise. We got rid of all the light pollution. We really show the nebula in beautiful colors, even with some structures here. We have beautiful stars in the background, in all colors, but actually in natural colors. So from that point of view, it is kind of incredible what you can do processing-wise with that quality of data. And I hope I was able here to demonstrate that it's worth investing your time, for example, for learning and also executing afterwards the GHS stretch, but also to invest the money in the RC Astro tools, because the improvements you can achieve with that are way higher from a monetary point of view than with any changes in your equipment. Okay, and with that, we're at the end, but only at the end of these beginner tutorials. You're now capable of doing basic processing of your picture and get a great result. And I would encourage you to practice now on this level, on different objects, on different of your pictures. And you will also encounter when you do that, that sometimes a process is needed, sometimes it's not needed, sometimes it's earlier needed. So besides the sequence in the linear stage, which I stated, this has to be done exactly like that, but otherwise you're really free. When and then how many places you use a curve transformation, for example, that really depends on your picture, on your situation. But once you're confident with these process steps, you can go on. You can start removing the stars and processing them separately. You can start with dual narrowband images to rip the channels apart, do SHO, false color images, and so on. The options are limitless, and you will also find in my playlists advanced tutorials who will show you that. I wish you much success, fulfillment, and fun on your further way exploring PixInsight, and I hope we see each other again in other videos and tutorials. To ensure that, please don't forget to subscribe to my channel, and to get all the information about this triology but also about other workflows, please join my Patreon channel. Link is also in the description below. See you next time, and clear skies.